Okay. Hi, everybody. My name is Rick Addante. I'm a senior lecturer at University of Texas at Dallas. It's a pleasure and honor to have a chance to talk with you guys a little bit today. I'm going to be speaking primarily about memory, and particularly about long-term memory and the medial temporal lobes. So everybody, hopefully, if they've been through basic introductory courses in neuroscience, has come across this idea that the medial temporal lobes are very important in certain aspects of memory, and also not very important in other aspects of memory. We'll introduce this idea a little bit as we move along today. So, okay, so I'm told this is a touch screen. So particularly the structure I'm going to be talking a lot about today is the hippocampus, and we've known for a long time, since Golgi studied it, as well as Cahal, and more recently, just this past year, it was work was recognized with the Nobel Prize of John O'Keefe and the Mosers for the role the hippocampus plays in memory, and particularly, even here this week, the cover of Journal of Neuroscience is featuring the hippocampus here this week at SfN. So we know the hippocampus is a critical component of the brain that's highly studied and a core feature of research in neuroscience, but it's really only recently that we've begun to understand a fundamental role that it plays in memory, and that stemmed from the classical finding from patient HM in 1957, which happened to be an accidental discovery, and it still remains a pillar of the field in terms of how we've dichotomized memory. So for those of you guys who might not remember, patient HM had intractable epilepsy. He underwent a bilateral medial temporal lobectomy, which resectioned both aspects of the anterior parts of his medial temporal lobe. You can see both of that here. And he lost the ability to perform conscious memory that we refer to as declarative memory. But one of his hallmark features was that he preserved the ability to do what we refer to as non-declarative memory, or memory that wasn't consciously accessible. He was able to demonstrate through different behavioral measures. So that gave us our sort of classical textbook dogma, which was that the type of memory unimpaired in patient HM was non-declarative memory is not dependent on the medial temporal lobe. So this is a snapshot from Gizaniga's book in Cognitive Neuroscience, but you can see it as sort of a ubiquitous point across most textbooks that most people use and teach how we understand our framework of memory. And it's given us this sort of canonical long-term memory sort of tree, or the declarative memory model, or the medial temporal lobe memory system. And what we have here is a taxonomy of memory based upon consciousness. So we have explicit or declarative memory that we can speak and say that we consciously recall, shown here in explicit memory, episodic, semantic, and we can contrast that with the type of memory that was unimpaired in patient HM and a handful of most of patients since then, called implicit memory or non-declarative memory. Okay, so that's sort of our classical framework, and it's sort of really spurred a lot of research in the field. Okay, so it basically created a watershed moment in 1957 when this was published, because we didn't know that the hippocampus played that type of a role in memory, and it really became a boon to the careers of Scoville and Milner, who initially reported it. Their graduate students went on to fame and fortune as well. Sue Corkin is at MIT, wrote this prominent book on patient HM. We now know Henry Molle-San. Post-mortem analysis revealed his name as well as the nature of his histological work, histological damage in the hippocampus, and it led to millions of dollars in funding being channeled to neuroscience, particularly to understand both memory and the hippocampus and memory systems larger beyond that as well. So we have that classical model, and this is shown from Candel's book again. So we have conscious explicit memory. It's thought to be served by the medial temporal lobe structures, particularly here the hippocampus. But we have this sort of division line, okay? Sort of the division line in this room, right? So that on this side, that conscious memory isn't supposed to be operating through the neural systems that serve implicit memory, and by vice versa, our non-conscious or non-declarative memory is not supposed to rely upon the medial temporal lobe. Okay, and this has come through a convergence of evidence, starting with patient HM, but also neuropsychological work since then, as well as neuroimaging work that's shown patterns of activation in the hippocampus in healthy normal subjects as well. So what I'm going to suggest to you is that this has become obviously the textbook dogma. Okay, so this is our Principles in Neuroscience from the 2000 Nobel laureate, who also did work on memory, but and what he said was that the implicit and explicit memory systems involve different brain systems, and implicit memory in particular does not depend on the medial temporal lobe structures. And what I'm going to try to suggest to you is the idea that perhaps that might not be the most accurate way to characterize memory. Okay? And the idea that I'd like to put forward is perhaps we've been looking at a three-dimensional issue with only a two-dimensional lens. Okay? So particularly the two methods that I just mentioned neuropsychological or behavioral work in studies of patients with damage to these areas have been complemented by another dimension of research, particularly neuroimaging, that shows the complement of that. So when you study fMRI approaches with memory, you can see that same area of the brain, the hippocampus, showing patterns of activation in certain types of explicit tasks. But nobody's really looked in a lot of implicit ways that this might show involvement in memory. For one, because we didn't think that it should. Patient HM showed us that when there's implicit forms of memory, it does not rely upon the hippocampus. And I like to challenge that. So particularly more recent work has come about that suggested that the medial temporal lobe in particular could be sensitive to whether things are basically old or new. So in memory studies you can say, did you see this before? Is this an old piece of information? Or is this something new that you don't remember? Okay? So we can show that the medial temporal lobe does actually discriminate some aspects of that non-consciously with fMRI, but it's very preliminary, and people weren't sure if it represented a fundamental role because it didn't view it necessary evidence, right? So it doesn't show that if you knock it out, that the process itself goes away. Okay? We know that the hippocampus has also been shown more recently to be involved in implicit associations. So there's an auto-associative role of the hippocampus known for forming associations and bindings between informations, but that doesn't mean that it's necessarily involved in a fundamental aspect of non-conscious memory, just the virtue of its associations or connections between other non-conscious things. Okay? So, let's see here. So, as I mentioned, we've had these two dimensions of research, basically behavioral and fMRI, that have converged to show this pattern of our textbook dogma, that non-conscious memory does not depend on the medial temporal lobe. But it might be possible that these two measures are also incredibly coarse. And what we're asking them to do are detect incredibly sensitive aspects of non-conscious memory. Perhaps they're just not able to detect what might be there. Okay? And one critical feature that has not been integrated with these lines of research yet has been sensitive physiology, particularly EEG, of non-conscious memory processing in patients who happen to have these rare forms of medial temporal lobe pathology. Okay? And so I'm going to describe some data that actually tried to bridge this gap. Okay? And raise the question of what if the hippocampus plays a more fundamental role than we've traditionally thought in implicit memory, perhaps even a necessary role if the structure happens to be knocked out. Okay? So I'm not going to go through all these details, but what I'm going to introduce to you is we had a patient group of 3 patients who had very selective and very carefully selected for inclusion into this study damage to the hippocampus. We can see that here. Whoops. We go back one. Forget about the porcupine for a moment. Damage to the hippocampus in this coronal slice, and this compared to a control subject. They had normal forms of explicit memory intact. Okay, and we can see the physiology of this explicit memory signal, this midfrontal, intact in both controls and patients. But the question is, how do you take an explicit memory task that they're consciously performing and measure implicit memory from that? And it's the same way that porcupines mate, which is very careful. Okay, yeah, totally was coming. All right, so the way that we did that very quickly for time's sake, what you can do is record EEG during a memory task, and you can very creatively capture non-conscious memory that people found in this posterior area of scalp signals, and you can compare the EEG for times when people say they don't remember, times when we say we forget, right? So their conscious report to you is saying, I don't remember. And you can compare that to when that conscious report is identical but accurate now, the times when it's a new item. And they also say, I accurately don't remember this, but this time it's true because it's a new item. And anywhere where it differs means that the brain is remembering what the mind has forgotten. Okay? Okay, so this is normal evidence from 1998 of posterior activity. We should see that in our healthy controls, and we'll ask, what does that look like? Is it intact or disrupted in patients with medial temporal lobe and hippocampal pathology? Okay? And this is what we find. Our normal pattern, like we just saw, replicated from 98, but when you look for the first time in patients with hippocampal specific damage, we can see an implicit deficit in a group level. These are the individual 3 subjects compared to our 6 controls. It's represented by, or quantified by a reliable condition by group interaction of this effect. And we can see this related to the hippocampal specific deficit. This is our normal pattern of activity. It's completely abolished. Okay, so for timing's sake, I'll cruise through the main point I'd like to make, which is that they're impaired in this new measure of ERPs of memory, of implicit memory, and suggests that a critical role of the hippocampus in this implicit memory process, perhaps rewiring the way that old and new items are differentiated after this damage, and it's challenging that core dogma that I actually spoke with Dr. Martinez earlier in the day, and I asked him, I said, I'm going to make this claim that the models of memory of declarative memory could be wrong, and he said, yeah, of course. Well, my point is, then why are the books still integrating that which much of the field has recognized that there are exceptions about? Okay, so for time I'd like to close there, and I'd be happy to talk about it later, and welcome your thoughts afterwards. Thank you.